In this section, we'll unpack how AI-generated content breaks our traditional assumptions about authenticity, identity, and evidence. You'll see why provenance suddenly matters everywhere, and what new technical requirements it creates for systems that need verifiable, tamper-evident records. If AI can generate infinite, flawless fakes, what does authentic even mean? The challenge isn't just deepfakes, it's that trust by default no longer works. In this course, we'll focus on engineering systems where claims must be proven, not simply believed. The threats from AI go far beyond fake memes or damaged reputations. They now strike at core business operations. Deepfake identity impersonation can trigger fraudulent wire transfers or approvals. Voice cloning can bypass call center authentication and voice biometrics. And realistic AI-generated documents can slip through manual checks. Verifiable trust has to assume these attacks are cheap, scalable, and continuous. Human judgment used to be our primary filter for truth. With modern AI, that filter breaks. We're biased to trust things that match our expectations, and we overtrust visual fidelity. Good lighting and texture feel real, even when they're synthetic. On top of that, the sheer volume of AI content means manual verification simply can't keep up with algorithmic scale. Legacy trust architectures assume a mostly honest center: trusted servers, admins, and logs. In an AI-driven, adversarial world, that black box becomes a liability. Data pipelines are opaque, refinement steps are unverifiable, and logs can be edited or deleted. Once metadata is stripped or modified, you lose provenance, and with it, the ability to prove what actually happened. Traditional systems say, "I trust this because it came from a known server." That assumes the server's identity and the surrounding infrastructure haven't been compromised. In a world of deepfakes, phishing, and insider abuse, that's fragile. The emerging approach is, "I trust this because I can verify its lifecycle." Provenance gives you an immutable, cryptographically rooted history of how something was created, transformed, and delivered. Trust shifts from reputation alone to verifiable history. C2PA is an industry effort to give digital content something like a nutrition label. Each asset carries cryptographically protected metadata about how it was created and modified. You can see who signed it, which tools were used, whether AI participated, and what edits occurred. That provenance can then be independently verified rather than just claimed. C2PA gives us a structured way to record the origin and edits of a piece of media. But on its own, it's still just metadata that could be tampered with. The key idea is to anchor that C2PA manifest to a blockchain. We hash the manifest, timestamp it, and record that commitment on-chain. Now anyone can independently verify the media's history without trusting a single platform, vendor, or government to maintain the record. Imagine every product leaving a factory is assigned a tiny secret seed. Each event in its life derives the next hash from the previous one, forming a forward-only chain. You don't need a blockchain here. The seed plus the latest hash proves the entire sequence. For humans, parts of the hash can be rendered as friendly bytemojis, so workers can visually spot tampering almost instantly. Regulation around AI isn't a distant future problem anymore. It's arriving fast and with teeth. New laws like the EU AI Act push us from trust us to prove it. You'll need traceability for high-risk systems, explainable decision paths, and hard evidence of data origin. And for synthetic media, expect strict labeling and auditable records to become the default. Quantum computing breaks today's dominant digital signatures, but it doesn't break everything equally. RSA and ECC identities, transactions, and consensus keys are fragile. Once short-scale machines exist, any recorded ciphertext or signature can eventually be forged. Hash-based structures like Merkle trees and content hashes remain much more robust. So the strategy is crypto agility. Design systems where signature schemes are swappable and anchor long-lived provenance to strong hash commitments. We're moving from trust because I said so to trust because you can verify it. Reputation and brand give way to cryptographic proofs. Manual log inspection is replaced by protocols where verification is automated and cheap. Data stops living in mutable silos and becomes a distributed append-only history. And the primary security goal shifts from guarding a hard perimeter to guaranteeing end-to-end data provenance and integrity. Treat these as a roadmap, not a wish list. First, adopt provenance standards like C2PA, so media and model artifacts carry signed histories by default. Second, anchor your highest value audit logs on decentralized ledgers, keeping raw data off-chain, but commitments immutable. Third, automate verification. Replace manual review with cryptographic checks wired into pipelines and monitoring. Finally, prepare for quantum by inventorying cryptography, preferring hash-based verification, and designing systems so signature schemes can be swapped without breaking everything. In this environment, every log, every model, and every identity claim in your system is suspect by default. The new competitive advantage isn't more data or more AI, it's proof. Your job as an architect is straightforward. Make everything verifiable. As you design systems, track 4 evolving anchors. C2PA gives you practical specs for content credentials. The EU AI Act shapes governance for high-risk AI. NIST's post-quantum standards guide long-term cryptography choices. And Blockchain Commons offers concrete patterns for provenance marks and decentralized identity.